Hello, everyone. Welcome. I'm Nora Randall, a 2021 Canals Fellow working in the Climate Program Office at NOAA. I'm here to welcome you to the fourth webinar in the series presented by the National Integrated Heat Health Information System, NIHIS, Urban Heat Island Community of Practice series. In the first webinar, we learned about the physical hazard of extreme heat on several spatial scales. The second webinar, Constructing Heat Vulnerability Indices, looked at assessing vulnerability and risk. In the third webinar, we started to investigate options. These webinars have been following the Climate Toolkit Steps to Resilience. In today's webinar, we'll be further exploring the step 3 of the toolkit, Investigate Options. This step examines possible solutions to the highest risks and builds a list of options through brainstorming and checking how other communities have responded to similar issues through inclusive community discussions. To discuss this topic, we have several fantastic speakers here with us today, starting with Kurt Schickman, who is the Executive Director of Global Cool Cities Alliance, a nonprofit that works with communities around the world to increase their heat resilience through the use of passive cooling measures. He will give a brief introduction to the technologies, practices, and designs that deliver passive cooling and increase resilience to heat in urban rural contexts. Then we will move on to several case studies followed by a Q&A session moderated by Kurt to wrap up. Before we begin, a few reminders. All the sessions will be recorded and posted to the NIHIS website and our YouTube channel. We encourage you to post questions throughout using the question chat function on GoToWebinar, which you can see in the control panel. So without further ado, I'm handing it over to you, Kurt.
Okay, thanks, Nora, and thanks all for tuning in to this webinar today in the series on extreme heat. And today we're exploring the materials, strategies, and designs that we have available today to mitigate urban heat and build heat resilience in our buildings and our communities. I'm not going to spend a lot of time introducing Cool Surfaces because I think the four great speakers that we have will do a great job of doing that for us. And they're going to share their experiences with how the built environment can build resilience to dangerous heat and support urban heat mitigation. We'll go from one speaker to the next, so please put any questions that you have into the question section, and then we'll address them all in a joint Q&A at the end. So up first today, we're going to have Sarah Schneider. She's the Deputy Director of the Cool Roof Rating Council, and she's going to discuss how solar reflective surfaces work and how they cool our buildings and communities. And then next up, we'll have Mark Conway, who's a member of the Baltimore City Council. He's going to share the work Baltimore has done to build heat resilience in the city. And he'll be followed up by Jackson Betchy, who's the program director at the Smart Surfaces Coalition. And he'll share an analysis that his group has done that highlights the economic impact of mitigating heat in Baltimore. And then finally, we'll be joined by Greg Spots, who's the Chief Sustainability Officer for the Los Angeles Bureau of Street Services. And he'll discuss the city's work with solar reflective cool pavement over the last close to 6 years now. So with that, I'm going to turn the floor over to Sarah. Sarah, the floor is yours. Looking forward to your presentation.
Thanks, Kurt. As Kurt said, my name is Sarah Schneider, and I'm the Deputy Director of the Cool Roof Rating Council, and or the CRRC for short. I'm going to give a brief overview of how buildings can combat urban heating. And I just want to make sure, sorry, I just need to switch screens here because I don't want to look at myself. Okay, so let's begin. I'm just going to give a brief background about the CRRC. So we are a 501c3 nonprofit organization that evaluates and labels the radiative performance of roofing and exterior wall products. We provide a public service through product ratings, research, and education, which supports the development of policies and programs centered around energy efficiency, climate resilience, and urban cooling through the use of cool roofs and solar reflective wall products. The CRC was formally established back in 1998 through a collaboration of stakeholders, including government agencies, national laboratories, energy utilities, environmental advocacy organizations, and many players in the roofing industry. The primary purpose of the organization was to create a third-party rating system for the radiative performance of roofing products that would support California's energy code, and to also serve as an educational resource to the public. We have since gone on to be a valuable resource that supports a wide range of codes and programs, promoting the use of cool roofs both here in the US and abroad. And as a 501c3 nonprofit organization, the CRC also educates the public about the benefits and impacts of cool roofs and walls in mitigating climate change and the impacts of the urban heat island effects. I think it's pretty evident that most people know and understand how buildings can contribute to the urban heat island effect by absorbing the sun's energy as heat. But buildings can also play a role in mitigating those impacts with the help of cool roofs and solar reflective walls. So in a nutshell, a cool roof or wall is one that efficiently reflects solar radiation while cooling itself by emitting thermal radiation. The metrics that determine the coolness of a roof or wall are solar reflectance and thermal emittance. And both of these properties are measured and rated on a scale of 0 to 1, where 1 is the most reflective or the most emissive. With respect to urban heat island mitigation, the greater the number of buildings in a given area with cool roofs and walls, the lower the outdoor ambient air temperature. And I think when people think about cool roofs or solar reflective walls, they tend to think of the color white. White naturally is the most reflective color out there, but with the advent of technology over the last couple of decades, there are many roofing and exterior wall products on the market that use infrared reflective pigments or reflective granules to achieve a higher solar reflectance. So on the screen here, you can see that the colors on top are categorized as cool colors, whereas the colors on the bottom are their conventional counterparts. So using black as an example, that particular black color uses a reflective pigment to achieve a solar reflectance of about 0.41 or 41% reflective, whereas the traditional black color below it achieves a much lower solar reflectance. So essentially the idea here is those that want to go for a certain aesthetic can still likely find products that will help reflect that solar radiation away from the roof or wall surface while preventing solar heat gain into the building. And this, of course, has implications for codes and standards and programs that have provisions for the reflectivity of building products. There is a multitude of benefits associated with using cool roofs and walls. For one, they help reduce indoor air temperatures by reducing the building's solar heat gain, which results in less air conditioning use, which in turn saves the home or building owner money. And on a larger scale, they help reduce energy demand and the strain on the electrical grid, which helps reduce the number of brownouts and blackouts during peak temperature times of the year or day. And of course, this reduction in energy use also helps decrease the generation of greenhouse gas emissions. And then cool roofs and walls also help reduce outdoor air temperatures, as I mentioned before, which of course help to mitigate the impacts of the urban heat island, but also they help to reduce ground level ozone, which contributes to smog formation at higher temperatures. This, of course, has implications for public health because of the improvement to outdoor air quality. And also in buildings without air conditioning, these materials can help the interior of the building be a little bit more tolerable during hot times of the day. So how are these materials evaluated? Well, the CRC has a product rating program that enables manufacturers and sellers to obtain radiative performance ratings for their roofing products, and starting this coming January for exterior wall products, which are then published on the CRC's Rated Products Directory and on CRC product labels. And through this rating program, product samples are tested in accordance with strict testing and weathering protocols. So essentially all product samples are tested initially by an accredited independent testing laboratory, and then they're sent out for 3 years of field exposure or weathering at accredited test farms at 3 designated US climates. And then after 3 years of field exposure, those weathered samples are sent back to an accredited independent test lab for what we call aged testing. And that data is what forms the basis for the product ratings that appear on the directory and on product labels. And I do want to point out, though, unlike certification programs like Energy Star, the CRC does not define what is a cool product. We rate many different types of commercially available roofing products and soon wall products. And that data is then used by entities like local government, for example, or program developers to establish the parameters that define what is a cool product and what is not a cool product. And since people rely on the accuracy of those product ratings to develop policy or procurement decisions, for example, data integrity is incredibly critical to the CRC. And we ensure this by vetting test methods and consensus-based standards through our technical committee and our board of directors. We only accept test data by approved accredited independent test labs and trained manufacturer test labs. We require 3-year weathering by accredited test farms in 3 designated climate zones, as I mentioned earlier. We also enforce a strict chain of custody through the testing, weathering, and rating processes to avoid tampering of product samples. And then finally, we operate a validation testing mechanism to verify that products in the marketplace accurately represent the products listed on the rated products directory. So what exactly is a third-party product rating? Well, in the context of the CRC, it informs end users about a product's ability to reduce solar heat gain into the building. It's based on measured radiative property test data, is measured and rated on a scale of 0 to 1, and it gives assurance that the data are unbiased because there is no affiliation with the manufacturing and selling of those products. And as I mentioned earlier, it is not a certification of a cool product. And third-party product ratings are important because they help consumers understand the energy efficiency of a given product. They provide consistency in measuring the radiative performance of those products, give more reliability to the marketing claims made by manufacturers of those products. And again, they support the development, compliance, and enforcement of various policies and programs that are trying to achieve certain goals, such as reducing urban heating, reaching climate goals, etc., through the use of reflective building materials. And lastly, I just want to share a few examples of various code standards and programs, primarily here in the US, that have provisions for the use of cool roofs and or solar reflective walls. This is not an exhaustive list, it's just an example. Many of these actually require or reference or rely upon CRC's third-party product ratings for compliance, as well as in developing the provisions in the first place. So the examples on the left-hand side, the left-hand column, are model codes and standards. Many of you probably are very familiar with these. They become mandatory upon adoption by a jurisdiction. So there are existing prescriptive requirements in all of these various model codes and standards, such as ASHRAE Standard 90.1, the International Energy Conservation Code, International Green Construction Code, etc. The examples in the center column are just a few cities and states that have adopted either building codes or ordinances or land use ordinances that are using cool roofs and or walls as a strategy for achieving various energy related and climate related and urban heating related goals. A few notable ones are, of course, New York City, Denver, and Los Angeles, as well as some less known ones, such as the city of Miami Beach that adopted an urban heat island ordinance a few years ago, and that's a land use or zoning ordinance instead of a building code. And then finally, in the last column are voluntary programs such as LEED and Green Globe certification, as well as a couple of city-run programs like the Louisville Cool Roof Rebate Program, and then the City of San Antonio's fantastic program, Under One Roof, where they actually pay for the installation of a cool roof on the homes of eligible low-income homeowners in San Antonio. And with that, I just want to say thank you for the opportunity to talk a little bit more about cool roofs and walls and the importance of third-party product ratings.
Thanks very much, Sarah. Next, we will be joined by Council Member Mark Conway of Baltimore. He's on the Baltimore City Council. Mark, the floor is yours. Go ahead and share your screen if you can, and look forward to hear your remarks.
There we go. Hey, how's it going, guys? Thanks for having me here today. I'm going to talk a little bit about heat in Baltimore and some associated problems that we see in Baltimore, and sort of what we've been doing about it historically and how we're thinking differently about that work going forward. So a little bit about myself. Of course, I'm a council member in Baltimore City, as we just stated. I'm also the executive vice president of the Chesapeake Conservancy, where we use data and analytics to improve conservation. And so, fortunately, I pulled together a number of different considerations when looking at issues having to do with heat. So first, when we think about Baltimore, just where we are, Baltimore, like many other cities, is really struggling with heat. And really from an equitable perspective, we're seeing that our lower income neighborhoods, our less treed neighborhoods are significantly hotter, somewhere to the tune of 10 to 14 degrees hotter than some of our well-treed and wealthier neighborhoods. So this disparity is something that we see not only in Baltimore, but we also see in other cities across the country. But it was first really looked into by NOAA, actually, in 2018. We had an opportunity to participate in this study. But interestingly, of course, this is a matter of built infrastructure, hard surfaces, dark surfaces that trap heat. But those surfaces also play an important factor in another major issue, or multiple major issues in the city. And of course, it's the heat island effect. But then also with more severe storms, we're seeing more flooding. It's really been troubling because, of course, we all just saw the impacts of the most recent hurricane to hit the East Coast, to hit New Orleans, and we're seeing that here in Baltimore as well. This picture of the flooding is just a couple of years ago. Fortunately, we didn't have anything too bad very recently, but we're still seeing significant flooding from moderate to severe rainstorms as a result. So typically, the way that we've really dealt with some of the heat issues that we've had have been cooling centers. We open cooling centers during the summer, during heat advisory events, where folks in neighborhoods can go to these cooling centers. They're big open spaces with tons of AC pumping. But unfortunately, we're not seeing quite the attendance that we'd like to see, the usage for those cooling centers that we'd like to see. Very recently, we've begun using Resiliency Hubs as well. And these Resiliency Hubs do a number of things. They distribute resources, whether it be fans or food, but then they also help folks in those communities to think about steps they can take in their homes to reduce the amount of energy that they're using and reduce the amount of heat that seeps into their home during the summer. More recently, we've been working with the Smart Surfaces Coalition. And the Smart Surfaces Coalition, I'm not going to take all of Jackson's thunder here, but they've really been looking into surfaces and how we can think about those surfaces within our city to better utilize our limited resources. Of course, we've always been thinking about trees, or more recently in the last decade, been thinking hard about trees, but thinking about our built infrastructure in a more strategic way has been new to the city. And so the research coming out of the Smart Surfaces Coalition, of course, looked at reflective roofs, green roofs, solar voltaic roofs, and porous pavements to deal with some of the stormwater issues that we're seeing, as I alluded to earlier. From that research, we're able to take that and use data, use land cover data to show the changes that we've seen over time in the city, and then use that to figure out where we have greater opportunities to plan for smart surfaces, whether it's rooftops or parking lots or parks and otherwise for trees. So, with the research, we saw a couple of things, and one of the most significant ones was the net present value of implementing these practices across the city, and it was estimated at $13.5 billion, which is 15 times more than the benefits cost to implement. And that resulted in significant decreases in temperatures during the summer. But I think, also resulted in jobs and a reduction in CO2. But I think what's really important here, and I think is really pivotal for urban areas, is that we've got limited space and we've got dense communities that result in some ways, a necessity of built infrastructure, and how to think about that infrastructure in a way that is getting the best bang for our square footage, dare I call it, is where I think smart surfaces have been really insightful and helpful for us. As we think about what we want to do going into the future, one of the things I'm looking at from the council side is how we can look into, of course, meeting the immediate need for AC. That would be policies around AC, distributing AC units, requiring AC units in buildings and otherwise, but then also looking at other policies having to do with shade, having to do with reflective roofs and otherwise, and requiring that on new roofs and significant updates to old roofs. So yeah, we're learning a lot here in Baltimore and looking to take some of the insights from the Smart Surfaces Coalition's research to inform the policies that we put forward here in the city, and hopefully make some change for everyday folks. Thank you. That's all I got.
Great. Thanks very much, Mark. Get my camera on here. Yeah. So before we introduce the next speaker, just want to remind folks that if you have questions as we go along, we're going to try to tackle them all at the end in one big Q&A roundup. So as you go, if you think of something, just go ahead and throw it in that question box, and we'll try to address it at the end of the session here. So with that, I'm going to turn it over to Jackson Betchy from the Smart Surfaces Coalition. Jackson, go ahead and share your screen, and looking forward to your remarks.
Great. Well, thank you, Kurt. Thank you, Nora, and as well as my fellow panelists, for letting me speak here today about some of the issues that that some of our cities are facing today, as well as some of the investments that they can make to, both improve their resiliency to heat, advance equity, improve public health, and a bunch of myriad benefits that go along with it. So we're gonna get started. Cool. So unfortunately, cities around the world, around the country, they look like this. They're overwhelmingly dominated by the presence of dark impervious surfaces. And all that these surfaces do essentially are trap heat, making cities and communities unlivable because of the urban heat island effect that I'm sure most of you are aware today. So you take a surface like asphalt, which has an albedo of roughly 0.05, that's actually absorbing 95% of incoming solar radiation. So as I said, when a surface absorbs that much solar radiation, it's making not only the individual building really hot and increasing the demand for AC, increasing the demand for electricity, but it's also making the ambient air around it really hot, worsening public health, worsening equity issues, etc. So in this picture, you can see, roofs, parking lots, roads, almost always are dark and impervious. And, we have to start to think, if these surfaces are so detrimental for our survival, for the health of our cities, then why do we continue to use them? And that question can be answered pretty simply, actually. So if you go to a city's Department of Transportation specifically, and you ask them, what do you think about when making a surface decision at the city level? And almost always they're going to exclude things like considerations for heat, air and water pollution, air and water quality, human health, equity, city bond rating, etc. And really they only look at lowest initial, lowest first cost, because they lack the actual expertise, authority, and tools to quantify the costs and benefits of the surfaces that they're deploying. And in response, foundations, cities, they've deployed pilot programs to try to address these problems in one-off solutions. One tree planting program here, another porous pavement program here. But when you think about the scale of the problem, this is not a climate disturbance. It's not a climate nuisance. We're in the midst of a climate crisis. So piecemeal approaches, while they have been effective in the past, are not effective at meeting the scale of the solution. So the Smart Services Coalition essentially quantifies the cost and benefits of these certain surface decisions to give cities the tools, the expertise to actually quantify these benefits, and so that they can actually deploy them in their cities and take advantage of the benefits that I've mentioned. Okay, so how did everything? Ooh. Okay, cool. Sorry, I don't know what just happened there. So this is really the future of surface decisions in cities that the Smart Services Coalition has a view for the future. If you look here, these dark impervious roofs turn into reflective roofs or green roofs. Sometimes they have combined solutions where solar PV is outlaid over a green roof or laid over a reflective surface, increasing the efficiency of the panel. You can see the roads are actually turning from dark and impervious to more reflective roads, and in some cases porous, taking advantage of the use of bioswales or bioretention in parking lots. But overall, increasing reflectivity, increasing porosity, that just makes cities healthier. It makes them more livable, more walkable, gets communities to be more active, and it ultimately transforms the way that cities think about their surface decisions to have a more resilient attitude. So, great. So this slide was on Mark's presentation, and he alluded to what smart services are, but smart services are essentially any surface that more effectively manages sunlight and rain. These can come in a few different categories, but in more effectively managing the sun and rain than the standard conventional surface, and you could think of like dark asphalt as that, smart services have lower life costs and increased livability as opposed to, as I said, the conventional surface. So, the couple of buckets that smart services falls on are A, surfaces that reflect light. So these can be reflective roofs and reflective pavements. We also include reflective pavement coatings, which Greg should touch on in the presentation after. We also include green infrastructure. So any kind of infrastructure that limits stormwater runoff. So these can be anything from porous pavements, sorry, not porous pavements. It can be anything from green roofs to, bioretaining parking lots, bioretaining roofs, any kind of natural infrastructure that slows the stormwater runoff. And then also we include porous pavements in that kind of bucket of slowing stormwater runoff. And then the last two sections we include are actually solar PV, so converting sunlight into electricity, as well as trees, which provide shading, clean the air and improve air quality. Also, there's an aesthetic benefit, and once again, increasing the livability of these communities. So this was another slide that was on Mark's presentation, and we were contracted by the ABLE Foundation in Baltimore to run a cost-benefit analysis of smart service adoption in the city or in Baltimore. And the results we found were pretty astounding and highlighted, especially you could see in this slide, the correlation between socioeconomic status and heat. You take a neighborhood like Roland Park, for example, which the tree coverage gets into the 20%, whereas Madison East End actually has a tree coverage of about 6%. The citywide goal is actually 40%. So 6% compared to a 40% goal kind of shows how low-income areas have been underinvested in terms of tree planting, green space, and this has also been exacerbated by a history of redlining, in the past, it seems like half century. So next slide. So we actually worked with Baltimore NGOs with the help of Mark, as obviously. We also worked with the Baltimore Neighborhood Indicators Alliance to set a target for Baltimore to adopt smart surfaces across the city over a 20-year period. And we actually quantified benefits and costs for an additional 10 years after. So it's really a 30-year calculation period. But these these targets all reflect Baltimore's own initiatives, Baltimore's own objectives for their, whether it's finance, climate, job creation, as well as from the input of local Baltimore NGOs. We've laid out a path for what seems like a feasible yet ambitious future for what Baltimore has in store in terms of smart surface adoption. So these next couple of slides will really highlight the actual cost and benefit calculations of certain surface decisions within Baltimore. And this first slide can show you the reflectivity in surfaces that we use. So we really look at roofs, parking, and reflective roads. And reflective roofs are the most effective, and especially in low slope roofs. Cool roofs are actually easier to be put on there, and their benefits are far greater than that of steep slope roofs. But we still include steep slope roofs because they still provide value for the city. But when you take things like road and parking lot that have a benefit cost ratio of 3 to 1 or 2 to 1, it doesn't seem like this is a super necessary measure to improve heat resilience in Baltimore. But at the same time, those two solutions contribute roughly 0.7 degrees of cooling to the city, and close to 1,000 job years created. So each surface kind of provides a unique value on their own, and they complement each other well, which is why we consistently push for the integration of different solutions to maximize cost and efficiency. So managing sun, we really look at solar PV on, again, low slope roofs and steep slope roofs. The benefit cost ratio for solar PV is really high because of a lot of these third-party financing options that are readily available for cities. And in doing these calculations and doing the third-party financing calculation, we assume that the initial costs, so like the financing payments, are actually equal to the net electricity value for the first 10 years. So these benefits actually aren't even assumed until year 11, but they contribute a great deal towards the economic case of solar PV on buildings in Baltimore, as well as the significant number in jobs created. So I know this is a webinar really focused on heat, but these two issues are really tied together in terms of our work, because we really look at surfaces that effectively manage heat and rain. So I won't go too much in detail on this, but these are just some of the services that we recommend for Baltimore, considering the high benefit cost yields after a lot of research, a lot of discussing with partner organizations, local NGOs about the benefit and cost assumptions that we make for these different surfaces. And lastly, trees are an important part of the set of solutions recommended for Baltimore. They create a significant amount of jobs and are the second largest contributor to temperature reduction outside of cool roofs. In general, they provide a great deal of shading. They look aesthetically pleasing, but overall, they provide a ton of value for Baltimore. And it's why Baltimore has been one of the only cities to actually increase their tree canopy over the last decade. So, as a result of quantifying these different surfaces and tailoring it towards Baltimore's needs and Baltimore's objectives, we found that over 20 years, the net present value is roughly $13.5 billion, with roughly a 4-degree peak temperature reduction. Thousands of jobs created, a significant reduction in Baltimore's carbon footprint, and the benefits far outweigh the costs. So you see in this number here, it's roughly a 15 to 1 benefit cost ratio when we factor in tourism. We actually assume a 5% summertime tourism loss due to extreme heat. It's kind of on par with a bunch of studies that have been done throughout the US and in Europe. But even without the tourism loss, benefits are still outweigh the cost by about 10 to 1. So it makes economic sense for Baltimore to start investing in these smart surfaces, not in piecemeal, as I've said, but as an integrated design strategy that should be the standard. I've talked about the coalition and how we quantify these benefits of smart surfaces. Guiding the coalition, you could see some of the relevant members on our steering committee. Our steering committee ranges from the CEO of the World Cement Association to the executive director of the American Public Health Association, with 40 plus industry leading partners, some in the US, some international, but essentially all of these groups and all of these people kind of organize themselves and and provide the expertise, the justification, and the validation for some of these cost and benefit assumptions that we're making, just so that every report we issue, every study we have is conservatively accurate, and we're not being overly ambitious. So that's all I have for you today. Feel free to email me and check out some of these resources, which I think Nora will put after the presentation. But thank you.
Great, thanks very much, Jackson. I'm going to turn it over to Greg Spots with the Los Angeles Bureau of Street Services. Greg, the floor is yours.
Hi, everybody. Let me try to present my screen here. Can you guys see that? Hopefully you guys see the presentation. Okay, great. Well, greetings, everybody from Los Angeles. I'm Greg Spots, Assistant Director and Chief Sustainability Officer for Streets LA. And in really 2014, we set out to be the first jurisdiction in California and perhaps the US to experiment with installing a cool pavement coating on a public street. We had partnered with a local organization called Climate Resolve and with another part of the federal government, Berkeley Labs. And although environmentalists and scientists felt that cool roadway surfaces were sort of an obvious play to reduce the heat island effect in cities, we found a report commissioned by the city of Chula Vista, California, that said this consultant couldn't find a single instance of a cool pavement coating being applied on a public street in California. It had only been tried really on the parking lots of office buildings that were seeking LEED certification. So we really wanted to innovate and be the first to do that. And here's why. If you look at California, at Southern California, from the EcoStress thermal camera aboard the International Space Station, you can see our entire road network because it's warm. These images have no base map. The only reason why you can see our streets and our freeways, our ports and our airports is that they are warmer on a summer day than the other parts of our terrain. And look at the one on the right. This is, at 4 o'clock in the morning. This is when we're supposed to be having our recharge from a hot summer day. And the health benefits of that recharge are being inhibited by this radiation of heat from all of these non-smart services that we have in the city. So in the beginning, we were having trouble even finding a commercially available product that claimed to be able to reduce the heat storage of an asphalt pavement. We finally found a product by a company called Guard Top. They're used to making a black seal coat for off-street parking, to refresh the look of like the parking lot at your supermarket. But they had made this gray color and started to discover that it was cooler, and that the titanium dioxide that was being used to lighten up this product also caused it to have the underlying structure absorb less heat. It started out being used on a few like airport runways and asphalt playgrounds at schools. And in the summer of 2017, we installed this product on 15 city blocks of LA, one in each of our 15 council districts. We installed it by hand with these sort of squeegees on a handle. It went down in 2 different coats, each about 50 microns thin. And we found that this product reduced the surface temperature of the pavement on a warm summer afternoon by about 10 degrees Fahrenheit. And we thought that was pretty significant. So then we set out to do neighborhood level pilots where we would place cool pavement coatings on multiple streets in a neighborhood and plant some shade trees. Now we know the shade trees we're planting, the 24-inch box trees, aren't going to produce substantial shade until they grow a little bit, but we decided to pair together the proven technique or proven intervention of shade trees with the emerging intervention of the cool pavement coating. And the first neighborhood project we did is in this neighborhood called Winnetka. in the West Valley of Los Angeles, in the West San Fernando Valley. It's this crescent-shaped street here and 5 cul-de-sacs that come off it. And we did this installation in May of 2019. And we did 4 other similar projects. So we now have 5 neighborhood level cooling projects. And we partnered with Jet Propulsion Laboratory, and we were able to see that crescent-shaped streets Stephanie Drive from space. That's right, these are images from the EcoStress thermal camera on the International Space Station. And if you go to this, this is our map of LA on a warm day. You can see all of our roads lighting up as hot. And then this is the Winnetka neighborhood. And here in the Winnetka neighborhood, this crescent here is this crescent right here. And it's actually a pretty comprehensive way to do this analysis. Ground-based sensors could be affected by wind. You're not going to get every single property owner to agree to put a sensor on their property. Some of them would be shaded, some of them would be not shaded. This is a way to kind of take a comprehensive look at a neighborhood. And interestingly, the pixels within 100 meters of our cool pavement streets were on average 2 degrees Fahrenheit cooler than the rest of the Winnetka neighborhood. And we thought that was really significant. I've made a lot of slides in my career, and this slide has turned out to be the most influential, and I'll tell you why. We supported our friends in the city of Phoenix with technical support when they decided to do a cool pavement project. They did a very large project coating hundreds of city blocks in Phoenix in the summer of 2020. And then I went to my boss and I said, okay, so we helped, but now they're Hertz and we're Avis, we're number 2. And my boss said, this is in the middle of the COVID financial crisis, come up with something so big that they can't say no. So we created a urban cooling committee within our agency. We used 3 different mapping tools. We used the Climate Smart Cities tool from the Trust for Public Land. We used the Google Tree Canopy tool that was created as a pilot for Los Angeles. That's part of Google Earth. And then there's a new tool called the Tree Equity Map that's national. And we used all 3 of those to match up places that are very hot with places that have low tree canopy, with places that are underserved neighborhoods. And we identified 8 underserved neighborhoods that are marked in blue on this map here. And we came up with a program to apply cool pavement coating on 200 city blocks across these 8 neighborhoods and plant 1,900 shade trees, including 600 that would involve cutting new tree wells where currently there's just a concrete sidewalk. And we were able to identify the $4 million needed to apply the cool pavement coating and the $2 million of the $4 million that we need to plant and water the trees. So we're very excited that we've gone from being an early piloter of smart surfaces as it pertains to the roadway to really being one of the first jurisdictions in the country to develop a program level approach that combines tree planting and cool pavement surfaces. And by June of 2022, we should have these 200 city blocks completed. Thank you.
Thanks very much, Greg. That was fantastic. We've now reached the moment where we can answer all the questions. We've got a lot of questions, so if the panelists wouldn't mind putting their cameras back on, I'll start to ask some of the questions that we've gotten from the audience today. So let me just get the questions open here. So I'm going to jump around just a little bit here, but I want to so I'll start with a question for. Sorry. Okay, I'm actually going to. The question is to Sarah first, and it says, "Are there any concerns for cool reflective walls increasing temperatures at street level?" And if the questioner will indulge me, I'm also going to ask Greg to respond to that with cool pavements in mind. So just issues related to temperatures at street level from solar reflective walls and pavements.
Yeah, so there have been conflicting research findings with respect to whether or not solar reflective or cool walls would increase temperatures at the street level. I think a lot more research needs to be conducted. It is, even though it's not a new technology, I mean, white walls have been around, think of Santorini, Greece, for example. It's a very famous example. So it's not a new technology to use light or white colored exteriors on buildings. But here in the US, it's still burgeoning in terms of application. So, the lack of extensive research and field studies, the jury's out. Anecdotally, I think there are some concerns, but when you think about the benefits, it's not a silver bullet, right? Like as Jackson mentioned earlier, there are a variety of solutions. So to each jurisdiction or area, the portfolio of solutions utilized is going to have to be sensible for that jurisdiction.
Thank you, Sarah. I think that was a really good way to describe it. On our end, in making the black asphalt gray, we're only bringing it into the range of color temperature that the concrete sidewalk already is. So we're not doing anything that you're not used to, and that, if you've walked on a concrete sidewalk in the summer, you're not going to feel any different than if you walked on a cool pavement street. And in fact, people only walk in the street for a very short period of time to get in and out of a car. So we're not really worried about that per se. It is a very complicated issue to study because there's short wave and long wave radiation. So, your lighter colored surface could reflect more light, and a little bit of that light could be experienced by a person as heat. But your darker colored surface is hotter and is radiating more heat. So it's a very complicated question to explore, but I think a really important way to look at it is through the public health lens. In Los Angeles, we're one of the only cities in America that has heat-related emergency room visits and deaths in the winter. We can have a heat wave in January that sends people to the emergency room. And generally, they're not going to the emergency room fainting on the sidewalk. They're going to the emergency room because they've been inside of a very hot dwelling that doesn't have air conditioning for hours and hours and hours. And they haven't been able to have that evening recharge because the city is staying very warm in the evenings, and there's some kind of like a hot, still air mass. There's a lot of meteorological conditions that produce these events. So I think lasering in on the public health outcomes, I think, can help us parse these questions.
Great, thank you, guys. The next question is to Mark Conway. So we heard from Jackson about the smart surfaces analysis in Baltimore. Has Baltimore adopted the strategies suggested by the heat study? And are you prioritizing one method over another? And if so, why is that?
Excellent question. So one of the things I'm currently working on now and hope to announce at the council level at the end of this month is implementing one of those strategies, and that's cool roofs. And so I think because implementing these strategies isn't just, you just do it, you've got to be thoughtful, think about the various considerations for city operations and otherwise. We're trying to be thoughtful in releasing these policies. But yeah, I think it's just taking it one step at a time. I think for us right now, the cool roofs one was pretty easy to put forward. It's been done before. I think it's tried and true. So I think we started there, and we'll see that actually come out at the end of this month.
Great, that's good news.
Yeah, I'm excited about it.
Yeah, to keep up on that. So Jackson, are the benefit cost results for Baltimore similar to results that you've seen in other communities? And a sub question to that: how much did the cost benefit analysis actually cost? So if other communities are interested in this type of analysis.
Yeah, so great question. Short answer is it differs city by city. So long answer, we estimate that on average, a city in the US will have roughly a 3-to-1 benefit cost ratio. But as we see with Baltimore, when you include tourism, that actually can raise to 15 to 1. Right now, we're working in Stockton, California, where the benefit cost ratio ends up around 9 to 1. So I think the story does not change from city to city. Every city has a set of different solutions that they can take advantage of that's like very specific towards their city. For example, green roofs don't really make sense economically in El Paso, but in Baltimore, they have a benefit cost ratio of roughly 4 to 1. So, you really got to look at what a city's objectives are and then tailor the services to meet that. But they're almost always in the positive range. And then to address the second question, the cost of the benefit cost assessment, that also depends on what a city wants to engage in. For example, it'll cost more if a city wants to look at specific low income areas in addition to citywide, in addition to maybe looking at a region or a state. But as the area increases, so will the benefit cost ratio. So we're looking in the $200,000 to $250,000 range per assessment, but that's kind of just like a baseline and always subject to change.
Great. Okay, Greg, I'm gonna group up two questions for you on sort of in the program in the weeds a little bit. So first, the question about how the program has been funded, the Cool Pavement program has been funded over the years. And then a second kind of related question is who did you work with at JPL to use the eco-stress data or to access the eco-stress data?
Great, yeah, second one is easy. We worked with a researcher named Glenn Hudley, and he helped do the post production to create those maps. But it's really exciting. Like if you have a tech savvy person on your staff, you can learn how to download and post process eco-stress data yourself. You don't even need a researcher necessarily. So it's really a great resource. We've gotten funding from the mayor and council that typically would be for other streets related projects, whether it's for maintenance coating of slurry seal or other types of greening or tree planting funding. We haven't gone out and gotten any external grants yet. We're just using city streets project related funding at this point. However, separately, we got a $30 million grant to do a holistic multi-benefit project involving cooling and active transportation at one of our transportation hubs in the valley. It's this place called Canoga, and we got $30 million from the state's active transportation program, and that's the largest grant they've ever given. And they said that this type of holistic multi-benefit project is what they're looking forward to seeing. So a really exciting kind of thing that all of us can explore is this nexus between mobility and cooling. Because if it's too hot to walk or bike to the rail stop or the transit node, people aren't going to do it. So we actually have to think about that last mile in terms of a heat aspect, as well as just getting people from here to there. Mark is nodding. I think he knows what I mean in Baltimore.
Great, thanks, Greg. Sarah, a question about costs. So someone was asking if you had some insights into the retail cost differences between a cool colored surface and a traditional surface.
Yeah, it's a great question. When it comes to paints or coatings, my understanding is that there isn't much of a cost premium. And sorry, Kurt, your face took me off guard. I'm like, am I on mute? Of course, for other types of roofing products like asphaltic shingles, for example, very, very common roofing product type across the US on steep sloped roofs. So talking mainly single family or multifamily pitched roofs. There are several big manufacturers out there that utilize a reflective granule, and that does have a cost premium associated with it. So it really comes down to the building owner weighing the costs and benefits and what they're trying to obtain or achieve in terms of energy or public health goals, which I guess a homeowner's not too concerned about public health, but if you really think about your community and what you can do to help your neighbors. For example, you know, some homeowners think like that. So, but yes, going back to the question, for reflective pigments in paints, there's my understanding is that there isn't a cost increase. And in fact, for coil-coated metal products that are designed to go on roofs and walls, they're already using those pigments. So there is no cost difference.
In LA, we have a cool roof ordinance for residential buildings, and I think 30 million square feet of cool roofing products have already been installed. And so I would say that the cool pavement surfaces are not as mature in terms of cost-effective solutions. But with Kurt, we're working on changing that with the Global Cool Cities, Cool Roadways Alliance. And we've got 25 cities who've issued an RFI to the industry for cost-effective, high-performing cool pavement products. And I think we're going to be able to bring those products into parity with traditional street maintenance coatings in the next 3 to 5 years.
Great, thanks, Greg. Mark, I'm not the only one excited about this imminent legislation. Would you be willing to share a copy of your legislation with the webinar participants, so that or suggest a place we can go for other municipalities to put one together?
Sure. I don't want to put it out before I put it out, but I will share it. So like I said, we're going to be putting out next week, I believe. We have another council meeting next week. After that goes out, I'd be more than happy to share it. But we learned from some other cities, including New York and otherwise, for what we're implementing. We're trying to go a little bit broader, but yeah, I'd be happy to share. I want more cities to do it. I think we should be learning from each other, and that's what we're doing here in Baltimore.
Fantastic. Jackson, I'm going to group up two questions for you. One about the content that was included in the CBA for Baltimore. Was health included, or how was health included in the cost-benefit analysis that Smart Surfaces Coalition did?
Yeah, great question. So we work with the American Public Health Association to give us different quantifications of certain health benefits that come with investing in specific smart surfaces. I think the EPA report says like 1,300-ish heat deaths a year or something like that. That's just off the top of my head, but you know, offsetting those heat deaths and illnesses that come as a result of, you know, unfairly hot temperatures is one way to incorporate it. But another is through the equity dimension. Because low-income areas are typically 8 to 10 degrees warmer than surrounding wealthier tree-lined areas, you know, this actually has a huge health benefit for communities that are the most at risk. But yeah.
And one follow-up question to that, a question about the Baltimore analysis specifically, and the cost of the Baltimore analysis. I know you mentioned a range of around 200 to 250 for the analysis. Can you be specific around what it was for Baltimore to get where you were with that analysis?
So Baltimore, off the top of my head, I don't know the number that was actually that ABLE actually contracted us for. So I haven't been at the coalition I was at the coalition while we were working on the Baltimore report, so I was not in the process of actually, you know, securing that contract or anything like that. But I will say for a project that we're thinking about doing with the SFO airport, that will cost roughly $250,000 if they look at both the airport campus as well as the surrounding neighborhoods, if that helps.
Great. So I see that we're at 3:59. So I want to give Nora an opportunity to add any remarks or closing things she wants to add. But we also have a lot more questions here. So if you, for some reason, you didn't get your question answered, please feel free to reach out to me by email, and I can kind of coordinate to get those answered for you. I'm at kurt@globalcoolcities.org, and I'll work with the staff at NOAA to get those answered for you. So thanks all, and over to you, Nora.
I just wanted to say thank you all to the speakers that generously took time out of their days to be here and present. We've had a fantastic webinar, and the questions and Q&A portion has been really interesting and engaging. Please, so next up, we're going to have our delve into green cooling infrastructure on September 30th at 3 p.m. Eastern Time. So please join us then. Keep sending in questions or email us questions. We're happy to hear from you. Thank you.
Great. Thanks all.
Thank
Thank you.
you.
Thanks, everyone.